This is Euclid Book 9, proposition number 18. Here's the diagram, folks. Okay, let's get into this, shall we? Given two numbers, to investigate whether it's possible to find a third proportional to them. Let A and B be the given two numbers, and let it be required to investigate whether it is possible to find a third proportional number to them. Now, A and B are either prime to one another or they are not. And if they are prime to one another, remember that they don't have to necessarily be prime numbers, just prime to each other. Okay? And if they are prime to one another, it has been proved that it is impossible to find a third proportional to them. How do we know this? By Euclid Book 9, proposition number 16. However, next, let A and B not be prime to one another. And let B, by multiplying itself, make C. Okay. B times B makes C. Okay. Then A either measures C or it does not measure C. First, let it measure it according to D. Now what that means is that, let's say A is 2 and C is 4. Then D would be 2 because A measures A measures C twice, okay? Because 2 times 2 is 4. That's what he's trying to say. But further, B has also, by multiplying itself, made C. Therefore, the product of A and D is equal to the square on B. In other words, you take A, you multiply it by D, and you find out that that product is equal to the square on B, which is B times itself. Okay. Therefore, as A is to B, so as B is to D. Okay. As A is to B, so as B is to D. That's what he's trying to say. Okay. And this is by Euclid Book 7, proposition number 19. Therefore, a third proportional number D has been found to A and B. Okay. Next, let A not measure C. Let's say that A is 2 and C is 5. Okay. I say that it is impossible to find a third proportional number to A and B. For if possible, let D, such third proportional, have been found. Therefore, the product of A and D is equal to the square on B. A times D equals B times B. Okay? But the square on B is C. Okay, so now we're saying B times B is C. Okay? Therefore, the product of A and D is equal to C. So we take A, we multiply it by D, and we get C. Hence, A, by multiplying D, has made C. Therefore, A measures C according to D. Just like I said before, let's say A is 2 and C is 4. So A would measure C twice, and D would be 2. Okay? Therefore, A measures C according to D. But by hypothesis, it also does not measure it, which is absurd. It either measures the number, or it doesn't measure it. Therefore, it is not possible to find a third proportional number to A and B when A does not measure C. And that is the whole proof. I will tell you more in my next video. Stay tuned.